Hello everyone. In this video lecture, we will see one more numericals based on Routh stability criterion. Okay. So we will take one characteristic equation and we will examine the stability of this particular characteristic equation. Right. So in the previous session, we have examined the stability of a given characteristic equation and we found that that particular characteristic equation was stable because there was no sign change in the first column. Right. Let us check this particular characteristic equation. So what we have to do is that we have to arrange the value of s from the highest power to the zero power, right? So in the first column, we can write s to the power 3, s to the power 2, s to the power 1 and s to the power 0. As the highest power is 3 and lowest power is of course 0. Now we have to arrange the coefficient in the Routh's array. So you can see that the coefficient of s to the power 3 is equal to 1. So we'll write it over here. Then we will jump to the s to the power 1 coefficient. So s to the power 1 has a coefficient equal to 3. After that we don't have any odd power. So we will keep 0 here. Next is we have to write down the coefficient of s to the power 2 which is equal to 2. After that the coefficient of s to the power 0 is 10. And later we don't have any coefficient of course. So you can see that we have filled up the first row and second row. Let us find out the coefficients of the next two rows. Let this coefficient is a1 and let this coefficient is a3. Let this coefficient is b0. We need to find out the value of a1, a3 and b0. So let us first find out the value of a1. Now a1 can be calculated as 2 into 3 minus 10 into 1, that is 2 into 3 minus 10 into 1 upon 2. So this is 6 minus 10 upon 2 which is minus 4 upon 2, that is equal to minus 2. So a1 is equal to minus 2. Next we will find out the value of a3. So a3 can be calculated by multiplying 2 into 0 minus 0 into 1 divided by 2. So a3 is equal to 2 into 0 minus 0 into 1 upon 2 and the result is 0. So my a3 value is 0. Next we will find out the value of b0. So let us find out the value of b0. Now b0 can be calculated by multiplying minus 2 into 10 upon 0 into 2 divided by minus 2. So this is minus 2 into 10 minus 0 into 2 upon minus 2. So the result will be minus 20 upon minus 2 which is equal to plus 10. So b0 value equal to plus 10. Right. So we have filled up all the Routh's array. Now we will check whether the first column has same sign or not. Right. So the first value of this column is positive. The second value is also positive. The third value is negative. Fourth value is positive. So we can say that we have two number of sign change. The first sign change is from this positive to negative. The second sign change is from negative to positive. So what we can conclude is that this particular system doesn't obey the necessary and sufficient conditions of Routh's array stability. So we can say this particular system is 100% unstable. So the system is unstable. Okay. So this is my first conclusion. Next, the second conclusion. Now the number of change of sign generally tells about how many number of poles are available in the right half of the S-plane. So basically we have two number of sign change. So two number of poles will be available in the right half of S-plane. Right. So this is all about this particular numerical. Right. So how did we proceed? Let us summarize this. So the question will be given as examine the stability of a given characteristic equation using Routh's stability criterion. So we have to first arrange the S value from the highest power to the zero power. We have arranged in the first column. Later on we keep on putting the values of coefficient in the first row, second row, third row and fourth row. First row we can put like this, as s to the power 3 has a coefficient equal to 1. Next s to the power 1 has a coefficient equal to 3. Next we don't have any s power, so we will put 0. Next the coefficient of s to the power 2 is 2, so we have written 2 here. After that s to the power 0 coefficient is 10, so we have written 10 here. Next we don't have any coefficient, so I can write 0 here. Okay. Next we will find out the rest of the coefficients. Let this coefficient is a1, this one is a3, and this one is b0. So a1 can be calculated by multiplying 2 into 3 minus 10 into 1 divided by 2, and the result is minus 2. So a1 is minus 2. Later on we can find out the value of a3. So a3 can be calculated by multiplying 0 into 1 minus 2 into 0 upon 2. So my result is 0. So we have found this particular row also. Next, b0 can be calculated by multiplying minus 2 into 10 minus 0 into 2 upon minus 2, and the result is minus 20 by minus 2, and the result is 10. So we have filled up, once we fill up all the coefficients of this particular Raoult's array, we will check whether the first column has same sign or a change of sign. So we can see that there are two number of sign change from this particular positive to negative and negative to positive. So I can say this particular system is unstable. The second conclusion what we get here is that two number of poles will be available in the right half of the S-plane because there are two number of sign changes. So in this way we can examine the stability of a given characteristic equation using Raoult stability criterion. In the next lecture we will see some different numericals based on Raoult stability criterion with some different conditions. Okay, thank you.